For centuries, humanity has looked up at the stars and dreamed of reaching them. We built rockets, powerful, explosive, and expensive machines, to break free from Earth's gravity. But rockets are a brute force solution, loud, risky, and costly. Imagine if getting to space was as simple as taking an elevator. This is the idea behind the space elevator, a cable stretching from Earth to space, offering a smooth, continuous ride. It's not just science fiction, the physics are real. A space elevator could make space travel routine and affordable, opening the cosmos to everyone, not just astronauts. It would slash the cost of reaching orbit, making satellites, telescopes, and even human spaceflight accessible. This isn't just about cheaper launches, it's about transforming space into a place for all of humanity. The space elevator could accelerate discovery, enable massive orbital construction, and serve as a permanent gateway to the solar system. The journey to build it is daunting, but the destination is a future where space is within everyone's reach. The dream of an easy ride to the stars is moving from imagination to engineering. The question is, how do we make it real? So what is a space elevator? Picture a cable anchored to Earth at the equator, stretching up 100,000 kilometers, far beyond geostationary orbit. At the top, a counterweight keeps the cable taut, balanced by Earth's gravity and centrifugal force. Robotic climbers would ascend the cable, powered by electricity beamed from the ground. No explosions, no rocket fuel, just a steady mechanical journey to space. The trip would take days, but it would be smooth and continuous. Multiple climbers could travel at once, carrying cargo, satellites, and eventually people. Once built, the elevator would slash the cost of reaching orbit from tens of thousands of dollars per kilogram to just a few hundred. It would transform space from a rare destination into a place for routine travel and commerce. Rockets would become the exception, not the rule. The space elevator would be a permanent highway to the stars. It's the orbital equivalent of building the first transcontinental railway. The challenge? Building a cable strong enough to survive the journey. That's where the real engineering begins. Let's look at the material that could make it possible. The biggest obstacle is the cable itself. It must be unimaginably strong and light. Steel and titanium aren't nearly strong enough. Enter carbon nanotubes and graphene, forms of carbon with incredible tensile strength. Carbon nanotubes are cylinders of carbon atoms, stronger than anything we've ever made. Graphene is a single layer of carbon atoms, 200 times stronger than steel. In theory, a ribbon woven from these materials could support a space elevator. The problem? We can only make them in tiny amounts. Manufacturing a flawless 100,000 kilometer ribbon is a colossal challenge. Scientists are racing to scale up production and perfect the process. The future of the space elevator depends on mastering these wonder materials. Material isn't the only challenge. Earth's atmosphere is harsh. The cable must survive winds, storms, and lightning, so the anchor would likely float in the calm equatorial Pacific. Above the atmosphere, space debris poses a constant threat. Even a paint chip could be disastrous. The elevator would need active avoidance systems and robust repair capabilities. Building the elevator means deploying a starter ribbon from orbit, then reinforcing it with robotic climbers. The structure will sway from the pull of the moon, sun, and moving climbers, requiring advanced stabilization. It's the largest engineering project ever imagined, demanding global cooperation. But these are engineering problems, and we've solved the impossible before. If we succeed, the space elevator will change everything. Science would leap forward. Giant telescopes, orbital labs, and interplanetary missions would become routine. Space industry would boom. Solar power satellites, asteroid mining, and zero-gravity manufacturing. Ordinary people could visit space, experience the overview effect, and even live in orbital habitats. The elevator would be our bridge to the cosmos, making space a place for everyone. It's more than engineering, it's a symbol of hope and collaboration. The journey will be long, but the dream is too powerful to ignore. One day, we may look back at rockets as the first step, before we built the stairway to the stars.